Hello, lovely class. I'm really sorry that I am at a conference today, but I'm sure I'm learning how to be a better teacher, so it'll all be worth it. Um, and I'm sure I'm thinking about you guys right now because I would rather be there with you. So today you're going to work through lesson 421 together. And I'm going to give you a little bit of instruction with this video, but mostly you're going to be investigating other parent graphs. So far we've investigated one parent graph, and that's y equals x squared. And how we investigated that was we played around with a bunch of different graphs. So that first day we had that activity sheet. You could even take that out today because that might be helpful. You might want to work through the ones that you're doing today, in a similar fashion. But basically, what you're going to be doing is you're going to be taking a parent graph, similar to y equals x squared, and you're going to be coming up with a general equation, like we did with y equals x squared. So when we investigated y equals x squared, we noticed things like if we changed the number that was multiplied by the x squared, we called that a, but if we changed that, what happened was our parabola changed its width. So let's just put this back to where it was. If we change the value of a, it got steeper or skinnier. So we noticed that, and so we put that into our formula. If we changed how far left or right we moved the parabola, what changed about the equation there was the number inside the parentheses. And if we changed how far up or down the parabola went, then the number outside the parentheses was changed. So altogether what we did was we started playing around with all these different values, and that's how things changed. So we did that, and we spent a couple days doing it, and then we found out that HK is the vertex and that A was the steepness. And then we could just basically draw, okay, this was our parabola of y equals x squared, that's the parent. But then if you had to, you could tell people that, hey, if I changed H and K, that I'd have a different vertex or something like that. You could draw it. So we spent a few days on that, and that's what you're going to be doing today, only you're going to be doing it with different parent graphs. So everybody should open their book, or each team should have a book, and you're going to be looking at lesson 421, page 182. So you can all read that introductory problem, which is problem on page 182, it's problem 459. You can read that to each other along with the discussion points. While you're doing that, the substitute teacher will pause the video. It'll only take you a couple minutes to read that, and then please start the video so that we can talk about what you're going to be doing. Okay, now that you've had a chance to read 462, you've seen that much like we investigated so the question here is, how can I transform any graph? So we see that we can transform the y equals x squared graph by moving it or sliding it over to HK, and maybe playing around with the steepness or the width of it, and that's how this changed. So the equation changed like that, the graph moved around, and that's how we could transform any graph. So this is the thing you're going to investigate about your new graphs, which are pointed out, which are these, whoops, move that down, these four. So that's what you're going to be doing today. So now that you've read what you're going to be doing, you'll see that 60, 61, and 62 kind of guide you through that. So I would highly recommend taking out a graphing calculator, and for each of the graphs given, so for example, one of the graphs given is the square root of x. So I might type in y equals second square root of x, and I might just investigate what that graph looks like. And now I might start playing around with some of the values with that graph, much like I played around with the values in the y equals x squared one. So one thing you might do is you might go inside there and instead of doing x, you might do x minus 6. You might investigate that. What does that graph look like? Oh, it moved. Not too shocking given what I learned about parabolas. And so on. So 460, 61, and 62 are going to kind of walk you through this process. So what you're going to do is the sub is going to hit the plate or the minute timer here. So you get 20 minutes to investigate that first one. Well, 20 minutes to investigate y equals square root of x. If you finish y equals the square root of x, please investigate all 4 of them. So go ahead and work on all 4 of these. Maybe the sub might want to stop this and let teams talk to each other, or maybe a team might want to come up and talk about something that they found. That would be perfectly fine as well. Or you might decide that you want to just work through all 4 of these as a team. At any rate, once you're finished with all 4 of them, you can hit play again, but right now pause to go ahead and do all 4 graphs and decide how you want to do that as a class. Make sure all 4 are done and then hit play. Okay, so you've had an opportunity to work on all 4 of those. Now you're going to make a poster. So problem 463 describes putting together a poster. So let's say I was going to put together a poster. One of the graphs I investigated was y equals x squared. I might say something like the transformation becomes y equals, and I like to use colors, as you know. So I would go ahead and put something like this into my, and then I'm going to just state every single thing I possibly can about that one graph. So for example, I might draw a graph. And of course, if I'm putting this on a poster, I'm going to be much more careful than I'm being here. But I might do something like that, and then I might do it in a different color. I might graph some of these and show how the vertex is different and show how it changed or whatever. But your job in 463, you can read that with your partners, is to put together a poster with all 4 of your new parent graphs and see how they look. If you want, you can hang them up around the room. And this B value is just any number. Pick a number. So if you want to pick 2, pick 2. If you want to pick 7, pick 7. If you want to pick a half, whatever. But anyway, that's what I'll be taking a look at to make sure your names are on it. And I'd like to see all 4 of those parent graphs represented. If you finish early today, you can go ahead and start working on the homework. At any rate, I miss you, and I'm looking forward to seeing you on Thursday. Good luck, and I hope this is a fun activity for you.